Hi everyone, Zach here, and welcome to lesson 92 of this RTS tutorial series. In this video, we'll continue working on our harvester tree. This is the second video where we're working on it, and we have just one more video on the harvester before we move on to our support unit. Once we finish our support unit, we will be done with this section of the tutorial, and then we will move on to our enemy AI and infantry units' individual behavior tree. Just a quick shout out to Nimian Games for helping support this channel as a Patreon supporter and helping this channel's content grow. If you want to help this channel out, consider becoming a supporter on Patreon. That said, fire up your projects and let's get started. Hey everyone, welcome back to the editor. And in this video, we're going to take care of our harvest branch on our harvester's tree. But before we do that, we need to clean up some stuff from earlier videos. And we're going to go to our harvester unit here. Let's pop that open. We need to make a couple of changes in here, but we're only going to start with one. I'll give you a hint that you might want to look around these three nodes about halfway into this lesson, I would say. When we finish the tasks, the first task we have to do, you might think about what can go wrong here. But the first thing I really want to do is I want to go to the end of our harvest where we set our resources back, or our harvested back to 0. There is something I skipped here, and we should just fix that right now. We're going to move this. We're going to grab this Boolean variable here and plug it into there. Grab both of these again, and we're going to leave it as false here. We set this as true elsewhere, so if we do find references, there's our false. We set it to true at the end of our start harvest. So we kind of needed that to go back to being false at some point. We needed that elsewhere as well. But let's leave this open because we're going to come back here. But for now, we are done with this blueprint. And let's open up our harvester. And let's open up our harvester unit tree here. And as you can see, we have our 2 branches. We're going to take care of this harvest branch, as I just mentioned. And like we've done previously, we're going to start with a wait here, and we're going to change the default wait time from 5 seconds to 0.5 seconds plus or minus 0.2 seconds. All right. The first task we're going to have to make will be to find our resources. Our second task will be move to those resources, which we don't need to make. We've already made it. And the third task will be to harvest those resources. It's actually that last task we're doing that relates to that error I was talking about a moment ago in the earlier blueprint. But let's grab our third task out of the 4 that go in here. It's actually the 4th task, the last task I meant. So let's grab that move to task. So we'll have our move to location. And we're just going to name this our move to resource. And we're going to set this to residence, or target location. Sorry, I misread what that is. Residence, location type, and status. All right. So now we need a task for our find resource and harvest resource. So let's create a new task using our blueprint task base there. And go back here. Let's rename this our BTT underscore find resource. And then I'm going to go into my task thing here, folder, and create a harvester subfolder. And then let's move that task into that subfolder. All right. With that in place, let's get started on this task. And this task is relatively simple. So we're going to start by receiving our event execute. I was going to say event tick. So our event receive. Hey, look, I got the I and the E in the right order, finally. Receive execute AI. And we're going to do our usual smart casting here of going to our harvester, not our unit master. And again, you really should not need me to walk you through this part by now, as we have done this at least 12 times. So yeah, the repetition should be setting into your mind how this is done. A lot of the stuff we have done is repetition, but it's unspaced out. So I've gone ahead and re-explained a lot of those things. But this, we do in almost every video now. Hopefully won't do it as much in the next section, but God only knows. All right. So what we need to do is we need to get the resources in the area. Now, I'm going to do a simple system where the AI can find any resource on the map, even if the player hasn't seen it yet. It's just like it's hunting for resources. However, if you want to add in a limit to the range in which it can see, then you can do that, and I will indicate at least one place you can do it. But I'll also hint at another method. So if you take a look at our flee to random location, you can use something from that in here to set up the sort of scan area they'll run around looking for things in. But we're just going to do the simple system where it can see everything. So we're going to get all actors of class. And again, I'll show you where you can implement another system in just a moment. And this will be of our RTS resource master. So we have our resource master there. Plug in a reroute. Let's grab all of that, including the reroute, and collapse it down to a macro. Reference cast. The reason I do all of the collapsing after is so that I can make sure I have the correct number of output pins and that everything lines up nicely. It isn't for any reason. I could actually just create the macro by creating it here, giving me the correct number of pins here. I'm just being lazy. And sometimes lazy is working smart. So we're getting all the resources. We're going to add this to a variable of resource list. And this will be our references again for that category. This will be our lists. And we're going to do a for each loop off of this array. And in this loop, what we are going to do is we are going to take the array element and we are going to get distance 2. Now, I'm going to take the unit reference and plug that into here. Before I go further, this right here is where you would start putting in your system. If this is, say, greater than 1,000 units, then it would not be added to the array I'm about to make. If it is less than 1,000 units, then it would be added to it. So that would give you a system. In fact, actually, let's just talk about how that would work. Let's do that system, because I don't like how this simple system is. So if the value between the two is less than a certain value, and I'm actually not going to pick 1,000, I'm probably going to pick 10,000. So it's 1,000, 10,000, and we're going to do a branch here. If this is true, then what we will do is we will take this value here. Actually, I'm going to probably do the reroute from coming underneath. Let's just line that up so it's a little bit neater. We are going to do add unique like we did with our engineer unit. Plug that down there. Plug that into there. Line those up. Bring that there. And we'll create a new variable from here, which will be our resource distances. So now it's not that simple system. It is that system where we are limited on where the unit will run. And let's toss this into our list category there. All right, so we can take all of this now, and we can collapse it down to a function. This will be our get distances function. Let's move that over here, break it for now, go into the function, and let's add in our return node off completed. There we go. All right. Now in here, what we're going to do is we're going to get our resource list. We are going to clear it. We are going to get our resource distances, and we are going to clear it as well. There we go. Plug that into there. Plug that into there. Take these two nodes, collapse down to function. This will be our clear lists function. All right. So now we have a reference to our unit. We clear our list if we have any. And then we set our distances, or get our distances, not set our distances, to resource targets within 1,000 centimeters, or unreal units, or 10,000. All right. So now that we've done that, we need to make sure there's a target for our unit to go to. So we're going to have a branch here. And what we're going to check for is the last index in this array. So we're going to get our resources distances. We're going to get the last index. And we're going to check if what is in this index, if the last item is greater than or equal to 0. Because if it is not at least equal to 0, then this is an empty array and the index won't be a valid one. And we will want to, if that's the case, return this player, return the control of the unit back to the player. So we're going to create a new function, which will be our status enum. And this we did in the last video as well, so you should be familiar with this. This will be our unit status enum. And we will set this to is idle off the false. We will then set a blackboard key selector to pass this information along. And this will be a blackboard key. Grab that status, get it, set blackboard as enum. Plug that into there and take the return value and plug it into value. All right. That looks really wonky right now, and it's driving me up the wall. There we go. And we'll also want to grab the unit at this point, just like before in the last video, and set automated to false. There we go. All right, so that's the easy part. If there is nothing there for the unit to grab onto and harvest, we'll just return the control of the unit back to the player. The next part we need to do is we need to actually set our target if there is something there. So let's grab our resources distance, and we're going to send them to the nearest one. Min float of array. We want to get from our resource list, and that is a copy, a reference to what is ever at the shortest distance. So these lists are made at the same time, so they should have roughly the same order, and since it loops through it, it will have the same order. So we'll plug that into there. If you don't understand what I just said, what I mean is since we create the list and then loop through it, when we add something here, it's going to be in the same order as, so what's in this list will be in the same order as what's in that list. All right, so I'll get the nearest target. We are going to take this value, but first we're going to take our unit reference as a getter, and we are going to set target resource. And we are going to set it to be whatever we get from there. Plug that into the true. And let's move this down just a bit. There we go. We are going to take from this get here, I just put a reroute into it, and we are going to get the resource entry. From our resource entry, we want to get its nearest collision. So get closest point on collision. And we are going to find our, again, our unit, and we want to know where the mesh of that unit is. So mesh, get mesh, and we want to know where in the world is Carmen San Diego. I mean our mesh. So get world location. We're going to take that world location and we're going to pass it into our point there. And so now we'll have a distance, or sorry, not distance, we'll have a vector that we can point our unit to. So we are going to create another blackboard key here, and that just reminds me that we need to make both of these keys something that can be edited outside of this window. So we have our target location now, and we are going to set our target location. So set as vector, and the return there will be the value we're plugging in. So now we've set our target location. Now I'm going to do something we haven't done in other videos, and I think we really should have been doing it, which is we are going to then add in 2 more variables. One will be our location type. And again, this is a Blackboard key. It's something we want to be able to edit. And our location type enum. And this will be in our enums folder. This will be our building names enum. And we're just going to grab off the back of that, set our enum to blank, and then set our target location, or sorry, our location type value as enum. We're going to set it, and we're going to pass in that information. Now, so our AI knows what to do. Our next step, because now we've done all this information, we need to tell the AI to go on to the next step in our sequence, is we need to finish, execute, and we are successful. So we do not fail out of the sequence. Go back to your behavior tree, and in the second position, your sequence between wait and move to resource, let's grab that find resource we've just made, and we're just going to rename this find resource. So our status should be status. Our location target location should be target location. And our location type is location type. So now the unit should move towards the resource. In fact, if we test it, let's make sure we gave the unit enough distance to find it. Go do job. It spins around a bit. It's now running to the resource. It's arrived. It's going to loop through that because it has nothing else to do. But at least we know it's working. It can see the resources. So let's go back to our behavior tree. Now what we need to do is we need to tell the system to harvest the resources. And this is where we have a lot of the work already done for us, but it is a bit complex because, as I said, there's an error. So I want you to think about, as we make this task, why I said we need to come back here and fix some stuff up. So let's go ahead and create that task, again, using our blueprint task base there. And let's go pop out into our main window, or into our main editor window, and rename this BTT underscore harvest resource. Again, this is just going to go into our tasks folder for our harvester. So move that there. All right. So the first thing we want to do is, as always, do our reference. Hey, again, 2 times a row in a video. I'm amazed. Do our reference cast off our event receive execute AI. And this, again, will be to our harvester unit, not our unit master. And again, I'm going to repeat, you should be comfortable doing this. If you're not entirely sure why we have to do it this way, just remember that we have no way to pull information from this unit in this particular class or in this particular blueprint. All right, so just like before, we'll do our usual is valid so that we know if we need to cast or not. If it is not valid, then we definitely want to cast so that next time we come through here, it is valid. And this one's really important because we actually will be running something on a tick. And I normally collapse this down after doing everything else. I'm just going to collapse this now. Collapse to macro. And this will be reference cast. I will add my output pin now, which will be then. It will be, of course, an execute. This will be execute. And this will be unit. All right. I haven't popped open one of these macros in ages. Let's pop that open. And I'd be horrified at how uneven everything is, probably. All right. We're just putting in everything into that output pin there. That's all we did that for. Why did we do it that way? Why did I do everything over here? Because the next thing we're doing is doing the tick. So we're going to do our receive 3 times in a... Okay, 3 times. And in a row, something is wrong here. Event tick AI. So we want the AI tick. We could actually use the normal tick here, but I prefer the AI tick just because I know it will be destroyed when this is done. So we're going to, when I say this is done, I mean when this is done. we're going to grab our unit reference. We're going to get it. We are going to pull from this our start harvesting function. So this is the function we wrote ages ago that allows units to harvest resources. We're going to put a reroute there and grab off of here. And we're going to search for is inventory full. Now you probably are starting to work out why I wanted to change how this works in the very beginning of this video. Now, it actually is going to fix an issue we would have had in the next video we'll do. But I figured we'll do everything in our unit harvester all in this video just to make life easier. So if our inventory is full once it's done with harvesting, what we want to do is we want to end our harvest. So to do that, what we're going to do is we're going to create a custom event. We actually don't need to do a custom event. We could just put everything off the true node. I just like proper encapsulation so I can see what is doing what. So I can see what is doing what. That was really hard to say. So when I went back to find the error of the is inventory full in my prep work, it took me ages just because everything was clustered together. If you separate things out into various functions, yes, it might take you a while to jump around and find things, but it does make it easier to find things that should be related to each other. All right. So if that's the case, what we are going to do is we are going to replicate something we have inside that unit harvester or harvester unit. We are going to reduce target resource. We're going to plug that into there. This is going to get a bit messy. We're going to put a reroute here. So I'm going to move this down here for a minute. We're going to get our target resource. And if you have that issue where it doesn't show up correctly, it will still connect to the reroute. Just like that. All right. Going to move that down there. Put a reroute in. I love how these end up being slightly less messy than my test versions. In my test versions, I spend time actually trying to make them look neat so I can actually read what I'm doing during the recordings. So once we've done that, we want to continue to pull off of this, and we want to destroy target resource. Again, remember, this only destroys the target resource if what we pass into it from the current value is equal to or less than 0. All right. So the next thing we have to do once we've done that is we have to clear our target resource. I have a feeling that's a setter, not a getter. Yep, that is a setter. I don't know why I kept doing this. So this is under resource related. We're going to rename that as set target resource. Thank you, Unit Master. Close that out. All right, so we set our target resource. There we go. As to nothing, so it's empty. We are then going to keep pulling off our unit reference there and get our time harvesting, and we're going to set that to 0. So again, we're replicating everything that's in our unit harvester. Now, the reason why we're doing it this way is there are added things in there that we do not need and that could cause issues with our AI. Also, it won't loop through properly if we use what was already in there, it wouldn't loop through correctly. At this point, this is when this task finishes. So we'll finish execute. It was successful. All right, save that. And let's go ahead and plug that into here. So that is our harvest resource. All right, so the couple of issues we have is that we will be running currently, if we did this, our harvest timers, so the start harvest thing here, twice. Once through a tick and once through a timer. Now, honestly, we could just run it this way, so this gets triggered, and we could just leave the tick to have the branch. Either approach, about the same. It really doesn't matter. The only thing you have to do if you're using the approach I'm doing right now is you need to add in a branch here. So I'm actually going to grab everything. because we're going to need to move it down a bit, and we're going to be editing some of these other functions as well. So we need a branch here, and in this branch, what we need it to do is we need it to check, is the unit automated? So is automated. If this is false, so it's not under the control of the AI, then we want it to do this. Funny part is, it really is still under control of the simple AI at this point. All right, when we end harvest, this is the tree we just replicated, so to speak. What we need to do is, again, we don't need it to run to the location. So with this one is a little bit more, we have to have it in for the ability to loop. We're going to have, when I say we have to have it in, we have to have the same branch in, or this will not loop correctly. So we're just going to move that over for a moment. Grab our branch node, plug that into there, and plug the false into that part. So again, if we didn't have that in there, when the unit was done harvesting resources, it would automatically find a building, which is useful, but we would have a problem getting back to the start point. I mean, actually, I'm sure you could do it this way, using a finite state machine set up like this, but it is simpler, I think, to not have it as a finite state machine, have it built into the AI in proper task orientation there. So in the hierarchical finite state machine setup. And again, we're going to repeat that same process with this final one for the end harvest early. By the way, if you notice that you're triggering the end harvest early, every single time except for the first time that the end harvest triggered, that was due to the fact that we didn't have this here. So the inventory was always full, which is what triggers this end early versus the harvest end. Sorry, I got that slightly backwards. Is inventory full, if that was false ever, would trigger the end harvest early because the resource would be empty almost always. If the end harvest always gets triggered, even if the resource was getting emptied, it was due to this not being there. But fortunately, that was covered by this little element here. All right. The main difference is, in this case, a unit was supposed to not run back to the building, but find another resource target to go to. And again, that's actually not something we built in. Our AI will be able to handle that. If we finish it early, because the resource is gone, it's going to check, do I still have room in my inventory? If so, find a new target. But that takes us through what we need to do for this video. So let's go ahead and test this sucker out, make sure it works. So we're going to just open that up, do job, wait for it to move. There's our unit. It's arrived. What we're going to do is we're going to go into here. We're going to go into our start harvesting, and there we are. We can see that it is harvesting, and wow, it's going slow because I haven't sped it up. Let's speed that up a bit. Please tell me the max is 1. All right. That is working. So we're seeing it's going through here. I'm going to pause the video. I'm going to put a breakpoint in before I do. Actually, I'm going to remove that breakpoint before I pause the video, and I'm going to put the breakpoint there. Hit resume, and I'll come back to the video when our unit has finished harvesting, and we'll wrap up everything we are doing. All right, welcome back. As you can see, we've hit that M point. So let's see what happens if we hit next. We come down here. It should take care of everything else. Let's hit resume real quick. We're going to come back here, apparently. We're going to hit resume again. The unit doesn't know what to do. So that is what we expect at this stage, mostly because we haven't told it what to do after it's done this. So once it gets to this stage, there we go. It's on the move somewhere. I'm not sure where it's moving to or why it's moving. It's tired. So it's moving because it's tired. So all that's happening here is because it doesn't know what to do at this point. It's just going, I can't do anything. We'll clean that up in the next video and finish out our harvester AI. So yeah, it was that simple. It was just a couple of things we had to do already based on things we've done previously. So that said, if you've enjoyed this video, go ahead and hit that like button and consider becoming a subscriber on Patreon to help support this channel out further. In addition, if you want to be here when we finish out the AI for our harvester units, go ahead and hit that subscribe and notify icon so you know when that video is out. And as always, I hope to see you in the next tutorial, and I hope that you have a wonderful day.